Welcome to solverfy.
Okay, so for this one, we're going to start with induction on K. So we have our recursive relation is equal to A times F of n over B plus Cn to the power of D. And it's worth noting here that we're given that n is equal to B to the power of K. And so this implies that K is going to be equal to log B of n for some constant K. Okay, so for our base case, the way that induction goes, we always start with our little base case. It's going to be if n equals 1 and K is equal to 0, then we would have C1 of n to the power of D plus C2 n to the power of log B A is going to equal C1 plus C2. Okay, and this is going to equal B to the power of D times C over B to the power of D minus A plus F1 plus B to the power of D times C over A minus B to the power of D. And when you sort that out, so you get these fractions over doing a common denominator, this is going to end up being just simply equal to F1. So now we know that our base case is equal to F1. So for the induction step, we assume is true for K. So we are assuming it's true for K with n being equal to B to the power of K. And then we want to see what happens with n being equal to B to the power of K plus 1. Right, so we have our f of n is equal to A times F over n over B plus C n to the power of D. Okay, so this is equal to A times B to the power of D times C over B to the power of D minus A times n over B to the power of D plus F1 plus B to the power of D times C over A minus B to the power of D times n over B to the power of log B of A plus C n to the power of D. So this whole big thing is equal to b to the power of d times c over b to the power of d minus a times n to the power of d times a over b to the power of d plus f of 1 plus b to the power of d times c over a minus b to the power of d times n log b of a plus c times n to the power of d. Okay, so then we can move some stuff around here. We'll get n to the power of d times ac over b to the power of d minus a plus c times b to the power of d minus a that needs to be a fraction. It's not quite enough room, so I'll rewrite it real quick. So that one is c times b to the power of d minus a over b to the power of d minus a plus f of 1 plus b to the power of d times c over a minus b to the power of d times c. And I'll take that whole chunk, multiply it by n to the power of log b of a. Okay, so we can simplify some things there. I'll head to the next page. So this is equal to b to the power of d times c over b to the power of d minus a. I'm going to multiply that by n to the power of d. I'll add that to f of 1 plus b to the power of d times c over a minus b to the power of d times n to the power of log b of a. Okay, well, the nice thing here is that this is, of course, our C1, and this is our C2. Okay, so it's actually equal to C1 n to the power of d plus C2 n to the power of log b of a, and the induction is complete.